Greetings and welcome to this review video. Now the purpose of this video is to review what we've gone over in Python so far. To that end, I am going to be explaining everything in fine detail. That's just how this video is going to work. It's a review video. That's what you do in a review. Now, there are a few things that we haven't covered yet, the big one being functions. Just kind of ignore the functions for now. We will be coming back to this project when we talk about functions to use it as an example. It doesn't really make that big of an impact on this project. So just kind of ignore the fact that we've got functions here. Don't worry too much about what they're doing. The important part is the individual lines of code. And so to start off, I am going to be jumping down to line 78, which is where sort of the main line of the program begins. But first, what is the intent of this program? What is it supposed to do? You might be familiar with the concept of a substitution cipher or a Caesar cipher as I know them. I have no idea if there's any actual historical connection to Caesar. I highly doubt it. But Caesar ciphers is what I know these as. And the general idea is that you have a letter and you shift it by a certain number of count. So if I am shifting by 1, A becomes B, B becomes C, so on and so forth. So the word dad, if I am shifting it by 1 with the Caesar cipher, would become EBE. And then when I want to decrypt, as long as I know that shift number, I just reverse it. So E becomes D and so on and so forth. And so I can change EBE back into DAD. It's the general theory behind how this works. It is an incredibly simple cipher. Don't ever actually try to use this for encryption. It is easily broken by hand. In fact, back in ye olde days, they had these things called newspapers, which is this really low quality paper that had words printed on it. And you could either get it daily or weekly. I am aware that some of you probably are old enough to actually remember newspapers, but many of you probably haven't ever actually seen one. Technology. But the point behind this little nostalgia trip is that in the funnies, which is the section of the newspaper that had comics, they would usually also have a couple of puzzles or brain teasers, and quite frequently they would have a couple of lines of scrambled text using a substitution cipher. And that's all you needed was a couple of lines, a couple of sentences, and you could break this stuff. So it's a party trick. It's kind of fun. Don't ever actually use this for actual encryption. But it's also a really good thing to use to demonstrate lists and loops and other basic programming techniques, which is why we're using it for this program. And so at the high level, this main part of the code, first off, we have the line shift equals 1. So we are declaring a variable. Variable declaration rules, you can only use letters, numbers, and the underscore. And the first character either has to be a character, has to be a letter, or the underscore. So shift is a valid variable name. Caesar is a valid variable name. Answer, the message, etc. All of these are valid variable names. Now, I am also initializing shift to a default value. While strictly speaking not necessary in most scenarios in Python, I do strongly recommend that you always initialize variables to a default value before you use them, with the one exception being when you are directly, oops, no, not there, when you are directly setting the value of the variable using input or a function or something else like that. That's about the only scenario in which I would say you don't have to. Even then, probably it never hurts. I should say, it never hurts to initialize a variable to a default value. Now we're going to ignore this for a moment. We'll come back and talk about try, except, finally statements when we look at error handling. But a simple version of that just simply is to use input. Anytime we need to get a response from the user on the console, we use input. And inside input, we pass in a string to indicate what message should we display to the user when we're prompting them for this input. Now, input gives us a string. If I mouse over input in Visual Studio Code, I can see that it tells me that it's going to return a string. That is not going to work if I want to interpret this input as a numeric value, which is why I have to cast it to an integer using the int function. So I have int, open parentheses, and then I am passing into this int function whatever string input gives me. Of course, if the user gives me something that cannot be cast to an integer, we will get a runtime exception error message right here, but we are assuming perfect input. Again, the input function, the display string, and if necessary, casting it to an int, which is necessary, and I'm storing that in the shift. Then we create the cipher. We'll come back to that. And then we prompt the user, are we encrypting or decrypting this? And in this one, there is no cast to an integer because, of course, in this scenario, I don't need it as an integer. I need it as a string. Now, this answer dot upper is not something I have used before, but if you've read through the string documentation, this is something you would have come across, and it does exactly what you think it does. It will take whatever string is contained inside of this variable, and it will convert it to all uppercase. So that way I've only got to check for one condition. Also, we have an if statement here. Remember, we've got several different versions of if statements. We have a fairly traditional if-else statement here. We could also have just an if, which we will see later on. Or I could have, if I've got multiple connections to check, an if, else if, or elif, as they are in Python. But an if, else if, else statement if I've got multiple conditions to check. Whatever you put after the if needs to be able to evaluate to true or false. And then we put a colon at the end of that line to let Python know that we're done with our conditional. An else statement does not have a true false. It will always be executed if you reach it. Remember, for an if else chain, as soon as one condition evaluates to be true, it will stop and it will not execute any of the others. So if this is true, the code associated with that logic, that question is executed, and this code will not be executed. But if this is false, then this code here will be executed. Also, for Python, since we have no line terminators, we use indents to help us determine what lines of code belong to other lines of code. So in other words, I use indents to tell Python that these two lines belong to this if statement. Visual Studio Code does give us some visualizers to help us see this. I have got this line here to indicate all the code that belongs to this if. And I've got another line here to indicate all the code that belongs to this else. This is also the same for loops, while loops, functions, anything that has code dependent on, whether or not the previous line was true or not, or executed, or so on and so forth. It's very important to pay attention to that indentation in Python. So if the user gave me an E, that means I need to encrypt. Again, I use input, prompt the user, what do I want to encrypt? And then I pass that string and my cipher into encrypt message. Again, we'll come back to that in a moment. And then finally, anytime that we want to display information to the user, we use a print statement. So I say print the message. And then the exact same logic is used for decrypting, except it's decrypt with the appropriate prompt. And again, I print it out. Now, what does this look like in action? Oh, if I run it, how many shifts? I'll tell it one shift. I want to encrypt, and I will encrypt dad. And like I discussed earlier, it returns EBE. And then if I run it, and again, I need one shift, and I want to decrypt this time, and I am decrypting EBE, it gives me dad. Now, it does work for larger, more complex text. For example, I asked Gemini to write me a 200-word story about a cat and a dog eating pizza for lunch. It is a very, very silly story, as per usual for AI-generated nonsense. And so I can take this story, copy it over, and run it. And this time I'll choose a larger shift. I'll choose an H shift just because, why not? I'll encrypt it. What do I want to encrypt? I want to paste that as one line. Yes, please. And there we go. It encrypted everything. And then I could, not going to, but I could then take all that encrypted text, run it back through, and it will work just fine. It will decrypt it just fine. So that's what it looks like in action. Let's hop back up to the top and take a look at some of the other code, because this is where our loops and our lists are going to be. So start off with, we'll come back to why that's called global variables when we look at this code for functions. There's a reason why this list is up here and not down below. But here we have an example of a list that is initialized with a set of values. I can tell this is a Python list because it has square brackets, not curly brackets, and not parentheses. And it is a comma separated, list of values. In this particular case, it's just simply a comma separated list of every letter in the alphabet. Now, it is worth noting that I call them arrays here. These are not arrays, they are lists. They look like, and for the most part, act like arrays in other languages, which is why I tend to make that mistake rather frequently when I talk about them. But I do want to stress, Python does not have arrays. Python has lists, tuples, sets, and dictionaries. They do not have arrays. So everything in here is a list. So what do I need to do? Well, from the description and from what we've seen demonstrated, I need a way of being able to map A to a different value. So if I have a single shift, A needs to become B, B needs to become C, so on and so forth. That is what I need to do. And so that's what creating Cypher is doing. It's creating that mapping of what do I need to map A to, B to, C to, so on and so forth. We do have a little bit of a sanity check. Again, we have an example of an if statement here that has no else or no elif or anything else. It's just an if statement. Yes, substitution ciphers do work with not beyond just shifting everything to the right. But in order to keep the code simple, I am only shifting things to the right. I am not allowing arbitrary shift values. It's not that it's hard, it just keeps the code simple. So I'm doing a sanity check if the shift amount is less than 1. And we have to always remember with if statements to have that colon and then the indentation to show these lines belong to the if. I will print an error message out to the user, and then I will stop doing stuff. Program will basically crash at this point. Next up, I need to declare a blank array. I don't know what this array should hold yet. That's what I need to calculate. But I do, not array, list. So I have to create a blank list now. It is important that you use an empty set of square brackets if you ever need to create a blank list. This is not a blank list. This is the empty string. This is not a blank list. This is an integer. This is a blank list. So that is very important. I need to create a list. I need to let Python know it's a list. I need to use the square brackets. Now, I need some way of going through every letter in the alphabet. So I'm going to use a for loop. The difference between a for loop and a while loop is a for loop, I know how many times I need to do a thing. I might not know it when I'm writing the code. In this particular case, I do. I know I need to do the thing 26 times. But as long as I know, whether by looking up some value or some other method, how many times I need to do something, I use a for loop. If I don't know how many times I need to do something, that is a while loop. Now, for loops in Python are designed to go through a collection, whether it be a list, set, or a tuple. And I need to use the index values. Why do I need to use the index values? Okay, so if we take a look at this, it's like, okay, if I'm shifting by 1, A needs to become B, right? If I look at this, remember lists always start counting from 0. So A is 0. I need to make A equal to B, and B's index is 1. Well, hey, if I'm shifting it by 1, if I just add that shift value to the index, does that work? Well, let's choose something different. What if the shift value is 3? So A shift 3, 1, 2, 3, should then become D. D's index is indeed 3. 0 plus 3 is 3. 1 plus 3 is 4. So on and so forth. So that pattern works. If I just take whatever index I'm on and I add the shift value to, that tells me what letter it should map to. So range and then a simple number inside will generate a list of numbers going from 0 to 1 less than you put in. So this will give me a range of a list of 0, 1, 2, 3, so on and so forth up to 25, which is what I need because that is index 25, not 26. And then the for I in range says, okay, generate that list, and then for every element in that list, stuff it into I one at a time. And we'll step through this code so you can see this in action. So TI, target index, yeah, could I have written that variable name out a bit more? Yes, probably. But TI stands for target index. So what I need to do is I need to take the current index, add the shift amount, and store that in the target index. But there's a gotcha that I got to watch out for. I'm on the letter Z. I'm in the last letter. My shift value is 1. That means Z needs to map to A. But I can't just add 1. This is 25. 25 plus 1 is 26. 26 does not exist. And so I need some way of detecting when I've walked off the edge and then wrap back around to the beginning. And to do that, I've got this oddly formatted if statement here. Now, on the test, you will not ever see me write a if statement like this, but I will write them like this from time to time if they are fairly simple. As long as you have a single statement associated with an if statement, like what we have here, you can combine them onto a single line. So this, if ti is greater than 25, colon, new line, appropriate tabs, ti minus equals 26, is just as valid as writing it like this. So it's just a little habit that I tend to have of if I can comfortably write an if statement on a single line, I will do so. But again, you will not see me write an if statement like that on any exam or anything like that. But again, we're asking the question, is ti greater than 25? Do keep in mind your operations, your operators for if statements. If you are checking equality, that is the double equal sign. A single equal sign is assignment. Double equal sign is equality. And then you have greater than, less than, greater than or equal to, less than or equal to. Make sure you are comfortable with all of these operators. This works because is 25 greater than 25? No, 25 is not greater than 25, so that will not return true. Is 26 greater than 25? In other words, I'm at the Z. I is 25, I plus shift is 26, TI is 26. So 26 is greater than 25. That is true. Subtract 26 from it. 26 minus 26 is 0. Oh, hey, that gives me the correct value that I'm expecting. When you want to add things to a list, you need to append it. So I am saying result dot append alphabet of TI. So again, so let's just take a look at that. So I'm going to put in a breakpoint. We will talk about breakpoints coming up here pretty quick. I am going to hit F5. I'm going to do a single shift. Now Visual Studio Code will give us quite a bit of helpers here. Now that I've broken in, you can see that result is currently blank. I is equal to 0. Shift amount is 1. And if I mouse over TI, you can see that TI is 1. So what I would expect, because remember, this first thing that I put in here is what does A map to? So I would expect a B to be put in there. And sure enough, a B is put in. Now I is 1, TI is 2. So now result has a C, and now it has a D, and now it has an E. This is what I would expect. If I've got a shift value of 1, A maps to B, B maps to C, C maps to D, so on and so forth. Okay. So that works. Now, what the heck is going on with all of these appends? For a moment, I'm going to take these out. I've just commented all of those out. Those are no longer in the code. This also helps illustrate, by the way, the importance of testing. The first version, writing this, I was testing it with simple inputs. Oops, that's how many shifts. So I have one shift. I want to encrypt. What am I encrypting? Hello world. Works just fine. 7 shifts. I want to encrypt. Hello world again. Okay, well, but I'm going to have to just take it at its face value that is correct because I don't actually know what it is. But yeah, it's just giving me different values, right? That's what I would expect. It is giving me different values. Okay, great, awesome. It's working. And then I tested something more complex. Boom, exception has occurred. Comma is not in the list. We'll come back to the encrypt message here in a moment. But basically, remember, we're looking up every time we encounter a character in either the encryption or decryption, we're looking up, okay, what should A map to? What should B map to? And now I ignore spaces, but then when I get to a comma, well, there's no comma here. Comma doesn't exist. Periods don't exist. Question marks don't exist. And so the moment I try to look up any punctuation, it breaks. That is why you always want to test and test with values that go beyond the basic safe values that you know should work. Now, there are several different potential, oops, that is not what I meant to do. Several different potential solutions to how we could approach this. I kind of chose a brute force method. Notice that I am appending in the same order to both alphabet and result the punctuation. Well, what's going to happen then, just put a quick little breakpoint here. If I run this code, and I take a look at the values in alphabet, index 26, period, index 27, comma, okay. And if I take a look at result, '26 period, 27 comma. What's happening here is I'm saying period maps to period, comma maps to comma. Because it wouldn't make sense for the substitution cipher to say, well, period will map to exclamation point, and comma will map to question mark. And I guess that means semicolon maps to A, and so on and so forth. It doesn't really make a lot of sense, right? So I didn't want to encrypt the punctuation. Oh, okay. So I just made them map to themselves. Period maps to period, comma maps to comma, so on and so forth. So that way there's no confusion. Now there is one interesting line here, line 29, and it's companion line, line 38. What's going on with this extra symbol here? It's like, am I putting in the punctuation slash mark? Am I putting, why do I have 3 quotation marks? Well, what I'm actually trying to put in is the quotation mark. I want quotation marks to work. And if we take a look at my code here, or the story, it's like, yeah, there's a quotation mark there. I need to have that mapped. What happens if you just try to put a quotation mark in? The entire thing turns red, right? Because the quotation mark is used to mark the beginning and end of a string, right? Whenever we do print quotation mark, error, la 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 la, quotation mark, those are used to mark the beginning and end of the string. So how does Python know the difference between this marks the beginning or end of a string and no, I actually want you to have a quotation mark here? Well, you do what's called escape codes. That's why we have the backslash here. The backslash is a special code that tells Python, hey, don't treat the next character after me as just a string. Don't interpret it in any special way. So that is why we have the backslash here in front of that quotation mark, because I'm putting quotation marks into the punctuation list so they don't get interpreted. Finally, let's take a look at encrypt message. I'm only going to look at encrypt message because encrypt and decrypt are literally identical, except encrypt goes from alphabet to key and decrypt goes from key to alphabet. Other than that, they are identical. So I have a source message, I have the key or the cipher, I have a result. Again, strictly speaking, do I have to pre-declare my variable here? Well, no, still a good idea. I'm going to take whatever source message I was given and I'm going to move everything to capital letters. Again, is this necessary? No, but it simplifies the code considerably. It's like it would not be difficult to accommodate for both lowercase and uppercase letters, but it would just messy up the code quite a bit. There'd be a lot more lines, and so that's why I'm just doing everything in capitals. Okay, we have a slightly different for loop this time. Potentially an easy way for doing one of the assignments from last week, or the week before spring break, I should say. Remember, for loops are designed to iterate over collections. What is a string but a collection of characters? So I am saying, however many characters are in this, and again, at this moment, when the code is hitting here at execution time, I know how many characters are in the string. I have the string. Even though I don't know this number now while I'm writing the code, I will know it when the code is running. So we are using a for loop here. I'm going to say for every single character in this string, stuff it into CHR one at a time, and we'll just go through this. So first I'm going to check for a space. Do remember, anytime you're dealing with spaces, a space is a character. It has a character code associated with it. You have to put the space in. This is not checking for a space. This is checking for the empty string, or a string with literally no characters. Make sure you pay attention to the difference on that. If you are checking for a space, make sure there's actually a space there. And if there is a space, I don't do anything with it. I just add it onto the result string. I don't care. Otherwise, I need to figure out what I am mapping and what I should map it to. Now, all lists, again, if you've read the documentation, like you were supposed to for your reading assignment, on lists, you will know that a list has a function called index that will allow you to find the first instance of an occurrence inside the list. That sounds like part of your assignment from the previous module. I can pass in a character, and index will tell me what is the first index that letter appears in. So if I am looking up the word dad, it will tell me that the first instance of the character D occurs at index 3. Now that I have that index value, I can look up in the cipher what is at index 3, because that tells me what D maps to. And so key of index, I look up that and I add that to result. And I just do that until it's finished. Let's take a look at that in action. So put a breakpoint in. Again, we'll keep things simple. We will do a single shift We are encrypting. The word is dad. So you can see here, the character we're looking at right now is D. Index is 3, like I said it would be. And if we look at the key, index 3 is E. And so if I do continue, result now contains an E. Now we're on A. A is index 0. If I look at the key, index 0 is B. Again, exactly what I would expect. I then allow that to run. Result is now EB. Do it one more time. Now result says EBE, which is what we would expect. And then decrypt works exactly the same way, except I'm looking up the index and the key and then pull in whatever value that is out of the alphabet. There we go. Completely functional code, working as intended. And that's your review for what we have done so far in Python. If you want to download this code and play around with it yourself, the link to my GitHub repository is in the description for the video. Obviously, this is under my private repository. You don't have the ability to push anything, so do not try to push. It will not let you. Do not try to make any pull requests or anything else like that. Just if you want to download it, that is fine. That is A-okay. Just don't try to commit any changes because it will not work. And with that, have a good afternoon.